Let's have a look at the workflow for how you would create a Lua-based test today in the web GUI. So it's more or less a three-step process where the first step is to create a user scenario, which is more or less a Lua script. And there are different ways to arrive at the Lua script. You can either hand code it, but it's more common that you would start off by, for example, doing a recording using our Chrome extension, or by converting a Postman collection using our Postman to Lua conversion tool. And once you have one of our scenarios, you can combine them into a test configuration and select from which regions you want to generate traffic, how much traffic you want to generate, etc. And when you have your test configuration, you can run it, and you can trigger a run in different ways. The easiest is to trigger it from the web GUI itself. So let's now head over to the web GUI and have a look at this workflow. So here I have a very simple Lua user scenario. I've just hand coded it myself. It generates requests against a very simple testing system that we have, and also requests to static resources. So once you have your Lua scenario like this, you would test it out by using the validation function here. So I can run a validation. And a validation is just a simple, small load test, one user running through the script once. And then you get your validation results here in the right panel. And we can see in this case that we have a request that failed. We couldn't find a resource. And if we look in the script here, we can see that we forgot a G here on our PNG file. So we edit that and we do another validation run. So it takes some time. We have to wait for the validation service to complete this small test execution. And there we go. This time it's successfully ran. So now we've completed the first step. We have our scenario. So now the second step is to create a test configuration based on this scenario. So go to the tests page here, create new test. We give this test a name. It's called webinar. We add our user scenario that we created. We can select a geographic region here. We're just going to use Ashburn, the default. We're going to create traffic simulation. We're going to say we're going to simulate up to 25 users, and we're going to create a very short test of 1 minute. Save the test. And then the third step is, now that you have your test configuration, you can run it. So I'm going to trigger run here from the web app. Now we get to the result page, and we're not actually going to stick around and look at the results. We're going to come back to the result a little bit later, but we're instead going to go back to the presentation now. And so if you intend to do any form of automation with your load tests, using the web UI quickly becomes tedious. And so for that use case, we have the Load Impact CLI instead. And the Load Impact CLI is written in Python, and it's available through the Python packaging index. So you can use the Python tool pip to install the CLI. So you would type pip install Load Impact CLI into a command line to install it. And then you would also need access to a version 3 API token that you can get from this URL here, app.loadimpact.com/account/token. And I'm not going to actually run a CLI test here. I'm going to show that later when we integrate our test into an automation pipeline. But this screenshot here shows a little bit what it looks like. So you type Load Impact test run and then a test ID here, and that triggers a run, and then you would get results streamed to the terminal. The other way that you could trigger a test run when you have a test configuration is by using the API directly. So here is an example in the screenshot here. We have used curl to trigger this post request to the Load Impact API. start a test run based on an ID here. And oh, by the way, the API token here is not valid anymore, so you cannot copy this API token and create tests under my account. Just so you know. Good. So now let's have a look at the process of steps that we have to go through at a high level to add our test to an automation pipeline. So the first thing that we need is the test configuration, which we've already created. The second step is that we need to run a baseline test. The third is to set up our conditions for pass or fail. And the fourth is to set up notifications so that we get notified when a test has failed, which is the interesting case. And then once we have those, we can actually integrate our test into an automation pipeline to trigger a test run. So the first step we've already completed. We have already created a test in the web app and the web GUI. So the second step is to run a baseline test. And a baseline test is a test you execute to find the normal performance levels of your system. So usually you're using a smaller amount of simulated users that you know that your system can handle, so that you can see the performance levels in terms of, for example, response time that your system is having under normal conditions. And so we'll consider the test we started previously in the web GUI as our baseline test, and we'll use the performance levels of that test as the input for the next step, which is to create thresholds. So thresholds you normally want to set slightly above the response times that you observe during your baseline tests. So you want them to act as guards in your automation pipeline. So if you have a performance regression, the thresholds would be hit, and that would fail the test and fail the pipeline, and you would be notified. So let's now go back to the web GUI here and look at the results. So now we have a result from the test that we triggered before. We scroll down here to the main chart, and we look at the blue graph here, and we can see that it's nice, flat, and stable, which is what we want from a test. So we can see that our system coped with the traffic volumes that we sent at it in a good way, and we can see that the response time here is around 450 milliseconds. So that's going to be our base performance level that we're going to use now when we go and set up thresholds. So we click our way to the configuration page here for our test, and we scroll down to the threshold section here. And we're going to add a threshold for the view load time, and we are specifying the failure criteria here. So the baseline test showed that we had a response time around 450 milliseconds. So that's our baseline performance. We're going to set a threshold here for 500 milliseconds. So slightly above our baseline performance. Okay, we're saving that for the automation pipeline for later. So now that we have threshold set up, we should decide how we want to be notified by the CI system when our test fails. And either you might have already set up a mechanism for being notified by your CI system, in which case you can more or less skip this step. But if you haven't, you can use the integrations that we have with Slack, HipChat, or a more generic webhook. So I'm just going to very quickly head back to the web GUI here to go to the integrations menu here in the sidebar. Scroll down, and we can find the integrations for those Slack, HipChat, and webhooks here. So I've already gotten a webhook URL here from Slack. So I went to the Slack service, and I created an integration. It's called an incoming webhook integration. And then you get this webhook URL that you can paste here in this input field. And just to test and make sure it's working, we can press this button test hook here. And then we can go to the Slack tab here, and we can see I just got a notification message sent to my Slack channel. All right. So now we have all the prerequisites completed to add our test to an automation pipeline. But before we head over to Jenkins, which we're going to use for the demonstration, I want to briefly touch on two common types of tests and how often it's suitable to trigger those types of tests. So the first one is when you're testing a smaller components, so say like a microservice or an individual API endpoint, for example. In those cases, usually the tests are quite small, and so they don't take too much time to run, and you can collect quite a lot of samples in a short amount of time, so your results actually contains value. And so those types of tests are possible to run very frequently, so perhaps even on every commit of code to said microservice or API repository. And the other type of test is the more complex one, so the more end-to-end types of tests, which they could be composed of several smaller tests that you've combined into a larger test, but they usually take a longer time to complete every iteration of the scenarios, which means that the test needs to run for a longer period of time to collect enough samples for the results to be valuable. So those types of tests are not really suitable for running on every commit unless you are a little bit sadistic and like having your CI builds take a long time to run, but usually that's not the case. So it's more appropriate to set up some kind of scheduling. So maybe running it, every once a day during the night or something, or once a week, whatever suits your release cycles for those types of tests. But let's head over to Jenkins now, so we can demo how to integrate this Lua-based load test into an automation pipeline. So I'm going to use, I have a locally set up Jenkins installation. It's just running in a Docker container here on my machine. And we're going to use the classic Jenkins UI here to start with. So we're going to create a new job. We're going to call it webinar Lua. It's going to be of the pipeline type. We're not going to do any configuration up here in the top. I can just briefly mention. So here you have build triggers. So as I mentioned, two different types of tests. So for shorter tests, you might want to hook this automation pipeline up to your version control system, so that if you commit or push a commit, that would trigger the automation pipeline to run. And similarly, if you have the more complex, longer end-to-end tests, you might set up a periodic trigger so that the test would be triggered every day or whatever is suitable for your release cycles, etc. Here's the interesting part. So setting up the actual pipeline. So Jenkins has this Groovy-based DSL for specifying the pipeline, so you can set up different steps, etc. So we're going to head over to my editor here and look at the pipeline script I have here. So it's quite simple. We have this agent declaration at the top, which basically it's a way to specify if you have a larger Jenkins installation, you can say that you want to run a pipeline on a specific machine that suits your requirements. But in this case, it's just a simple environment, so we just specify any. We specify an environment variable here that we need because we're going to trigger a test run using the Load Impact CLI, and the CLI needs access to an API token. So we basically pull in the API token from the Jenkins credential store here. So we have a credential called Load Impact v3 API token that we just referred to here. And then this is the actual pipeline here. So we have just one stage and one step, which is a shell execution, invoking the Load Impact CLI and telling it to run a test with a specific ID. And actually, I need to change this, so this is not the correct one. So I'm going to go to the web GUI here, go to tests, click on our webinar test. And up here in the URL bar, you can find the test ID. So I'm just going to copy this, go back to my editor, and replace this ID. And now I'm going to copy the entire pipeline script here, go back to Jenkins, paste that in there, apply, save. And since this is just a demonstration, I'm just going to trigger a build manually here. Here we go, the build is running. Let's go and have a look at the output. So we can see now that Jenkins is running this pipeline. It's executing the only build step that we have, which is to run the load test. So it has invoked the Load Impact CLI, which is now initializing a test. And as the test is running, the CLI will continuously print. It's going to be roughly every 3 seconds to the terminal here, information of how the test is progressing. So we first get the timestamp. Second column here contains the virtual user, so the number of currently simulated users. We have the throughput expressed as a request per second. And then in the fourth column, we have bandwidth expressed as bytes per second. And then we have in the fifth column, user load time. And we can see here the user load time is hovering around 450 milliseconds roughly, which is what we saw also in our baseline test. So luckily, the system is performing equally well to a couple of minutes ago when we ran the baseline test. So nothing has happened to our testing system here, which is good. And then the last column here, we can see a failure rate, but we don't have any failures, so it looks all good. And I can also mention that if these default metrics being printed here from the CLI, if those are not the ones that you are looking for, you can configure that as part of your Load Impact CLI invocation, so you can select other metrics that are more interesting for your specific case, if that's the case. So now we see that the CLI has reached 25 users, which is the target level, and now it's just gracefully shutting down here. And the thresholds will be evaluated also, and if a threshold is actually hit, the Load Impact CLI will exit with the non-zero exit code, signaling to Jenkins that this test has failed. So we'll see what is, okay, so now it's finished successfully. As we can see, the load time here was all around or lower than the threshold that we have set up in the configuration. So this run was successful, and if we go back here to the dashboard, we can see that this run was successful. It took a total of 2 minutes to run this pipeline. So that's it in terms of the pipeline.